if you want to compare two independent groups, okay, we can use two independent sample t-test in condition that the data are normally distributed. The test statistic formula, we use the t-statistic. This is the formula with the pool standard deviation as this one, and then 101 minus alpha % confidence interval for mu1 minus mu2 is as follows. So for example, let x1 and x2 represent the reading of blood pressure for patients with anemia and without anemia. So we have x1 and x2. A researcher claimed that patients with anemia have lower blood pressure than those that do not have anemia problem. Test the claim whether it is true or not at 5% level of significance. So the hypothesis statement, the null hypothesis, we always assume that the mean for the both group are equal, and then the alternative hypothesis is based on the claim here. Patients with anemia have lower blood pressure than those that do not have anemia problem. So we want to test whether mu1 is less than mu2. And then to compute the test statistic, we use this formulation. Okay, x1 bar minus x2 bar minus mu1 minus mu2 divided by the pool standard deviation over SP square root of 1 over n1 plus 1 over n2. But before that, you need to compute the pool standard deviation first. Okay, so let's say the pool standard deviation is here. Okay, but before that, let me copy paste this data first, x1 and x2. Copy. Okay, and then paste here. And then okay, compute the SP dulu. Okay, the pool standard deviation P. Okay, the pool standard deviation is based on this formulation. Actually, this is supposed to be a square root. Okay, so therefore the value of SP, okay, that you should get is 2.404471. Okay, it's based on the x1 and x2 here. Okay, and then after that we can compute the test statistic. Okay, so the test statistic, this one, the t count. Okay, so I just copy the formula. Okay, so mean x1 minus mean x2 minus 0, because mu1 minus mu2 is equal to 0. Okay, divide by the SP multiplied by the square root of 1 over n1, 1 over n1 plus 1 over n2. Paste. Okay, and then run. So the test statistic that we obtain here is equal to negative 3.273855. Okay, and then after that we compute the critical value. Okay, so since the alternative hypothesis mu1 less than mu2, so this is a left tail test. Okay, for a left tail test, you don't have to minus 1 with the probability value, because the R programming will compute the probability of less than. So therefore, okay, just compute the probability of the t cup with the degree of freedom n1 plus n2 minus 2. Okay, copy and then paste this one. So we use the PT. PT is the probability of the t distribution. Okay, so the t count, and then insert the t count, and then insert the degree of freedom n1 plus n2 minus 2. So the value of PT is equal to 0.004811628. Okay, so how to make a conclusion, or how to make a decision and conclusion? So based on the p-value, we compare with the alpha equal to 0.05. If the p-value less than 0.05, reject the null hypothesis and then conclude there is enough evidence to support the researcher's claim. Okay, where the researchers claim that patients with anemia have lower blood pressure than those that do not have anemia problem. And then we can also the built-in function in R to perform the independent t-test. Okay, so this is the coding. Okay, we use the t-test and then include the x1 and x2. So the alternative, since we want to test mu1 less than mu2, so we put the alternative equal to less, and then we use the variance, we assume that the variance for both group are equal, so we type var dot equal to true. Okay, so run, and then you will see that, okay, you will get the t value is the same as the t value as you compute manually. Okay, the p value also is the same. Okay, so the interpretation also will be the same. Okay, and then if you want to obtain the 95% confidence interval of the mean difference, okay, as usual, instead of less, this one, okay, you can run this one. Okay, just change less into two-sided. Okay, and then you will get the confidence interval. Okay, 95% confidence interval. If you want to compute the 95% confidence interval for the mean difference manually, okay, based on this formulation, okay, x1 bar minus x2 bar plus minus the critical value t alpha over 2 and 1 plus n2 minus 2 multiplied by the margin of multiplied by the standard error. Okay, so use this formula, okay, and then run. Okay, so you will get the lower and the upper limit. Okay, and then it's the same as using the built-in function of the t-test. Okay, and then if you have the data, okay, in a data frame, okay, let's say we have the, let's say we combine this data and then put them in a data frame. Okay, so we use this coding. Okay, so data frame, okay, we create a column, okay, x1 and x2, okay, for the BP, and then the second column is for group. Okay, so we replicate with, okay, how many times according to the length of x1, and then we replicate the word without how many times according to the length of x2. Okay, so therefore, okay, if I run the blood data here, okay, you can see that, okay, the data which is in a vector form, x1 and x2 being combined into a data frame. Okay, if your data is in a data frame, so how to run the t-test? Okay, so you can use this command, okay, t-test Okay, BP, okay, we want to compare the blood pressure according to group. Okay, with and without. The data, okay, is from the blood, alternative last, and then variance dot equal is equal to true. Okay, run. So you will get the same result. Okay.